Hello everyone, welcome to this finite element support Abaqus YouTube channel. In today's video we'll see on crack propagation. Crack propagation using extended finite element method. So if this 2D object is given with in a case simulated like a half-fold at one end. So the crack is started at this stem point and propagates throughout its widest. So how the propagation looks like, we'll see the procedure. So if you see how the crack started from one point, this point and propagate throughout its length. So let's start a step-by-step procedure. Go to new, create part name as it is, or can do this 2D planar shell and put it is 1 because we'll use a meter unit. So go to this rectangle and put in this way, then dimension it 0.4 and this one 0.1. So here bring the center at the midpoint, radius 0.05 and see measure from this center point. Up to this is 0.2, it's on halfway. Then let's put this 0,0 point here and move this object into this. Let's fix this one first. Fix it, select this point. Okay, so when you select this and translate into this object will move because this one is already fixed. So go to here and choose move, select entities, you see. Okay, then this point move towards this one, then trim this part to these two parts, then okay. Then go to property module, then create a material, traction, then maximum points damage here, maximum stress, match in sub option, damage evaluation. Then this, let's select energy and this BK property to get nodal mode fracture energy, and here fracture energy for first direction and second direction. So here 2780 2718, the same value. Let's edit this one. Energy power is equals to 1. Then sub option damage valuation or cohesive coefficient 1e minus 0 for this match value. Go to this mechanical elastic property and put this Young's modulus 52.2a the power of 8, then 0.3 poisonous ratio. Then create section solid homogeneous, then assign a material for this part, then go to assembly and create part instance. Okay, then go to step and stop module as it is static general, then go to put that as it is time period and change this incrementation like and for initial increment size just lower from 1 to this much value. Then in field output request can go to change some parts in failure and fracture. This is initial field, this extended finite element method for this value. Okay, then go to interaction. In interaction we will create this equation constraint. Before that, let's assign some reference point. So reference point in this middle part and this lower part. Then go to this assembly, then create set this bottom and select this bottom edge. Okay, top, select this edge. Okay, then bottom displacement, select this point, and top displacement. Select this reference point. Okay, so we have this 4 sets. So go to here interaction, then create equation constraint, continuing coefficient, let's 1, set name bottom, in degree of freedom is 2, let -1 in that means in other direction. So bottom displacement, and here degree of freedom is 2. in the same way. For top 1, date 1 set name top, then 2, and coefficient for this top displacement -1, degree of freedom is equals to. Okay, because then go to this special tab, then crack and create this crack. Before that, let create partition, go to part, then draw a very small line here, short line. So later on we'll put this as a starting point of crack. And for the purpose of mesh, they create a partition from this part, one line, then from this let's add more partition here from and okay, we made a partition here. So go to interaction, then go to special, crack, create crack using this XFAM, that means extended finite element method. So select this all part. Okay, so if you need this crack propagation, where crack propagation started, you can check this crack location and pick this line. Otherwise you can use as a default, because mostly it's already known, because the crack is started at this thin place around here. But to make sure, just select this crack location and choose this line. So you select the crack propagation starting point, but you don't know where the crack is propagate, around this or straight line, or down in the bottom line. So see this after the analysis completion. So go to load, create boundary condition, displacement rotation in step module, then select this part. Okay, then in Y, positive Y direction, match 0.01 upward. Displacement for this bottom line, boundary condition 2, select this bottom edge. Okay, then put 0.0 or equal displacement but in different direction. Okay, so it looks like this. Then go to mesh, let's import instance. This a little bit coarse mesh, then 0.07. let's try this. Then select and encode and structural. Okay, how it says the region highlighted in magneta are too complex for structured meshing. It says this one is what the magneta highlighted part. So how correct this mesh problem? Let's click one more partition here, extended from this crack starting point. Let's go to part and then select this one, then go to line and start from this, draw one straight line. So if you go to mesh, I hope it will remove that problem. So if we select this part and set as quad structured mesh type, so normal it's okay. So let's mesh this one. Okay, to refine the mesh around the crack length, select this part, these two edges, then let's by number and refine this around this. Okay, I have 10 elements. Then select this and this two edge. Also put this 10 number of elements. Then mesh it. So the mesh is okay. Then go to this material assignment, select all this part, then here plane stress, that's okay. Just remove this radius integration. So this CPS for not bilinear plane stress quadrilateral element. Then go to save it. Let's set work directory. Go to this part, anywhere you need. Just select one folder, then this crack. So everything's saved here in crack folder. Then save as. Propagation. Then create job. Okay, then submit this part and we'll wait for result. Okay, it says the analysis is supported. So if you go to monitor and see how the problem happen here is the time increment required is less than the minimum specified, it says. So to correct this or to remove this problem, you go to step and change this incrementation to minimum. This initially it was 0.1 or can put 0.01. Mostly this incrementation may not get correction for that problem, so let's add one more boundary condition. This problem has happened mostly because of insufficient boundary condition. You see, go to this boundary condition and edit this one, boundary condition 1. You set edit here and on a region select edit region and pick this point instead of the edge. Select this top displacement, this point, so that the displacement is applied here. Similarly for the bottom one, select this region, then bottom displacement. Okay, so we have this two boundary condition and one more boundary condition in initial step, displacement, rotation, and as it is, you consider this as a full 2D problem and apply here symmetry on this line. So let's select this to edge. Okay, then in x direction constraint as like symmetry. Okay, then go to job module, then submit, and we'll wait for the result. Okay, the analysis completed, so go to result and see how this crack propagations started and propagate through the length. So go to here in step, see this, the initial or the point where crack started. Here we set already, then it will propagate throughout this length in this way. So we see status in XFM, that is displacement or any other stress car. If you want any other parameters, first you go to in this step and edit this one, select whatever you require, it's up to you. Select any stress, displacement, or any contact, pressure, anything else you can choose from here in field output requests. Then finally we'll get on that result. Okay, this is all about today's video. If you need more, you can write in comment section. And if you are new for this channel, please subscribe and like, share. Thank you for watching.